Good day everyone, my name is Jubel Ontoria and I will discussing the chapter 6 of the book titled of Drainage and Slope Protection. So now we will discuss what is drainage. Drainage is defined as the means of collecting, transporting, and disposing of surface water originating in or near the right of way or flowing in the stream, crossing or bordering the right way. So like we see in the picture. So ito yung example ng mga drainage like in the highway or sa street or sa mga subdivisions, sa mga highway. Next. Approximately about 25% of roadway funds are spent for culverts, bridge, and other drainage structure. Bigger approximation are also allotted to ditches, dikes, channels, and erosion control structures of rural roads like major capital investment are channeled to urban areas for storm drains and other pertainous plus the routine clearing of drainage facilities. So this is the example of the projects of drainage. So some of our government projects is focused in these projects like culvert, bridge, and drainage structure. Next. Surface drainage is only one among the many problems to be considered in establishing the location of construction of the road. The most favorable location of the road as far as drainage is concerned in the division between the large drainage area. So one of the most problem is the surface problem because sometimes the surface is not equal or have a problem and the location. So roadway location parallel with the large stream should be avoided because it will cross every tributary canal leading to the stream. Steep grades and heavy cuts and fill should likewise be avoided for it will be contribute to the problem of erosion. So sabi dito dapat daw maayos yung roadway location para walang mga erosion. Kasi kapag hindi maayos yung roadway location, so pag mag-ulan, so makakaroon ng mga erosion at masisira yung road at yung drainage system. Next. Surface drainage problem follow three basic consideration. So first, hydraulic design that deals with estimating the highest rate of runoff be handled. So this is the first problem in a surface drainage. Then the hydraulic design that deals with estimating the highest rate of runoff to be handled. Number 2, hydraulic design deals with the selection of the kinds of sizes of the drainage facilities that is most economical to accommodate and estimate the water flow. And the third problem is erosion control is to be ascertained. The design will not create erosion or other acceptable and environmental condition. So this is the three problem in the surface problem follow in the basic consideration. This is the three. Next, we will discuss what is the hydrology. Hydrology is the branch of the physical geography that deals with water of the earth. The branch of hydrology that concern highways engineer are first, the frequency and the intensity of precipitation. Second, the frequencies that this precipitation bring the highest. runoff which are equal or exceeded critical values. Third, distribution of the precipitation throughout the season that influence water behavior affecting the highway surface. Next, the fourth, the prediction of regarding future rainfalls or runoff that gather statistical approaches, formula, or simulated methods based on the law of probability. So this is the hydrology. It's a branch of physical geography. So like we see in the picture, this is the studies of may focus ng hydrology like the water, the land, at sa mga stream ng mga daanan ng water. So importante na isang engineer ay may alam din sa hydrology. Ayan, next. Concomitant thereof are method of predicting may be subject to substantial error. Therefore, design should be make the best possible use of existing method which full of expectation of high behavior or high probability error. And so, when we design a drainage or water system, mayroon talagang mga error na mangyayari. So, dapat lagi tayong merong backup plan or prepared sa mga ganyang mga bagay. So, runoff is predicted based on the following methods. So, there are 5 methods in the runoff. First, by the rational methods. Second, by the empirical formula. Third, by the unit hygrograph. Fourth, by the statistical approach. Fifth, by simulation. So this is the 5 basic method of runoff. And next, relationship and effects of hydraulics and so first, usually highway construction disrupted existing natural drainage pattern. Water passing the natural right-of-way is often intercepted by roads cut. The flow of the several streams are collected to pass under the highway through a single channel, diverting stream to a canal or culverts that differ in the size and length, concluding the flow characteristic from the previous one. Second, construction operates may be disturb the ground cover and loosen the soil, creating muddy stream as a result of erosion. Third, erosion creates debris that are carried downstream and deposit and points where the velocity slacken. Records show that almost every drainage installation disrupted. Fourth, any changes in the land use may alter the historical runoff or an ungauged rural watershed that could be disastrous on a wide-scale basis. Ayan. So, this is the 4 sometimes that we must understand in the relationship effect of the hydraulic and construction. So, must review this in the book so that we can understand better. And next, cardinal rules on drainage system. So there are 2 cardinal rules in the drainage system, in the drainage design. First, as much as possible, any existing drainage system patterns and soil cover should not be disturbed. Second, necessary changes in the drainage pattern should not in in any manner bring velocities that may create new erosion problems. So we must understand these two cardinal rules in drainage design. So importante daw na meron tayong pattern and soil cover para hindi ma-disrupt yung soil. At sa second naman is SAR changes is drainage pattern should in a manner be velocity that creates new erosion. So dapat maging prepared tayo sa magiging erosion kapag mali yung paggawa natin. So dapat in the right way. So non-observance of these simple rules are created many serious problems in the past, and worse, the people put their blame on those who were not involved in the making of the highway unslightly. So if may problem talaga yung mga drainage na gawa natin, so mag-create ng erosion. So ang mag-suffer is yung mga tao at yung place at yung government nandun, kasi magiging isang big problem dahil magbaha at yung mga erosion is madamage yung mga house at yung mga highways nila. So importante na ma-understand at ma-remember natin yung mga basic at yung mga rules and problems na ma-resolve agad. Next, drainage economic consideration. The term economy in drainage system simply means finding the solution to the problem that is cheapest in the long run under the following condition. So it is important na sa future civil engineer na ma-understand ito, na finding solution to the problem that is cheapest in the long under run following conditions. So there are three drainage economic consideration. First, or elements of road and highways. First, determine the estimate essential investment costs. Second, consider the maintenance costs or outlay. And the third, anticipated loss and damage for each solution. So we must understand and remember these three drainage economical consideration. Ayan. Next. So under the foregoing consideration, rural approximation for possible drainage or economic loss is equal to the estimated losses from floods of various magnitude multiplied by the probability that these floods will occur any time of the year. For instance, if the drainage loss from any flooding exceeding the designed flow example is 200,000 pesos, in according to the hydraulic computation, such floods will occur once in 5 years. Then the annual loss of the floods damage is 200,000 divided by 5 years, or 40,000 per year. Drainage problem is varied and there is no single set or change yung words or rules to economic problem and drainage consideration. The uncertainty of the flood frequency where the design is based to major highways with large volume of traffic losses to motorists and to the economy, and tremendously high if the road will be closed frequently due to the flood washout. So this is the most problem, and if meron makakaroon ng problem sa drainage at makakaroon ng erosion, so marami madadamage, so makakreate ng malaking cost sa government at sa economy, at maraming maapektuhan tulad ng mga motorists at mga tao at yung mga commuters. Yan, next. For major highways, projection might prove that the drainage facility should be accommodate a 50-year flood, whereas the design based on a 5-year flood is vulnerable for our low volume rural roads. So it's important that yung drainage na ma-design at magawa is 50-year flood, ibig sabihin, yung capacity niya pang 50 years. So, hindi siya agad-agad nasisira within following years. So, may lifespan siya na 50 years. Ayan. Where drainage problem of any magnitude has alternate solution economic studies based on reasonable estimate cost, and the possible damage represent the best approach. Flood frequencies and some of the costs must be thoroughly approximated, and less catastrophic occurrence per bird or perspective on cost risks. Next, uh, draining the highway. Rain water flow laterally or oblique on the surface of the road prevent under the influence of the cross section of slope or super elevation in the pavement and shoulder. The water flow is controlled, then the shoulder is danger of erosion. However, the shoulder will be minimal erosion damage if it's the already covered and protected by the proper grass. So, if meron daw mga rain at mag-erosion, so ang shoulder, di ba sa highway, merong shoulder, di ba? So, shoulder sa pinakagilid, so, ibig sabihin kapag may erosion, so, una daw matatabunan ng lupa is yung shoulder. So, importante na madrain at malinis agad yun para walang madamage sa highway. Drainage and slope protection. First, water flowing across the road, down the road slope must be thin enough and a sheet from like so that the erosion of the tire shoulder will be minimized. Second, unprotected slope could be badly washed out in irregular in the pavement or shoulder accumulate water in a small stream. Another point of water accumulation that endanger the shoulder is the low portion of the such vertical curve. Third, one way of preventing washout of the side slope is to retain the water at the outer edge of the shoulder. Ayan. Next, the fifth and fourth, a crown ditch or intercepting channel may be employed at the top of the cut slope. This will prevent erosion of the cut slope by surface runoff from the hillside above. The surface should not be disturbed in any manner where the natural ground is already covered with grass or other ground cover. 6. The channel or canal should be formed making the original ground as its bed in small dike, topsoil, or imported the material to serve as it banks. 7. Scoring must be controlled. If possible, the water flow must be limited to a severe amount by diverting the flow at intervals. Water should be dropped down to the roadside ditch means specially designed and do it on the channel. So dito sa illustration, sa presentation, so ito yung example ng pag-resolve at pag-design dapat ng isang drainage. So, may cut slope, pavement slope, so may mga measurement at mga degree. Ayan, sa low fill slope, so this is an example, the third slope not less than 0.12, pavement slope or approximately 0.4. So, we must review this. And roadway center line. So, example, this is the great example na ma-understand yung number 1 to number 7. So, it's in the picture. So, next, draining the urban street. Oops. And, so, this is the formula in calculating the so we must review this in the book. So in the formula, rational formula is the Q is quantity of the runoff in cubic foot per second. And the C is a runoff coefficient expressing the rate of the runoff to the rate of rainfall. The I is the intensity of the rainfall in inches per hour for a duration equal to the time concentration. The AD is drainage area and the acres. So, hindi ko naman discuss yung 1 to 4 dahil nag-iba yung mga letter pag transport ko sa WPS galing Microsoft. So, we was review na lang sa book sa chapter 6.1 to 0.4. So, next. So, on the freeway and the urban streets, the inlets of the gutter in the median should pass the designed flood without clogging with debris. So, this is the table. So, based in the book, sa table 6.1, suggested value coefficient runoff C for use of the rational formula, the type of drainage area, and the coefficient runoff. So, this is the table suggested that we must understand and we remember. And so the forest area, the cultivate field, the turf, meadow, the bare earth, highways or for the step slope, the gravel roadways open, concrete and bituminous pavement. And thank you everyone for the listening. So I invite you to review our book chapter 6 chapter 6.1 to 0.4 because thank you everyone, bye.